Great. Hello, everyone. I'm Daniel. I am currently a PhD student at Virginia Tech, doing pretty much switched my thesis topic a couple of months ago, doing data science education, mainly focused for medical practitioners. So if you work in medicine, if you're a physician or a nurse, let's talk about how you can learn R or Python. This past summer, I was an intern at RStudio, and I worked on a package called Grade This, which is a code grader for Learn R documents. So if you are in the education space and you want to create something like a data camp lesson or a code academy lesson in that type of style, you can do that yourself. And then this is an auto grader that tries to say, hey, I expected you to use the function called sum when you use the function called mean. And I learned very quickly that to generate that sentence is very difficult. So I am also, like Jared said, I wrote this book about this other programming language, and this is what this talk is about, because we are at our R conference, and I'm going to talk about Python. So R and Python. All I did was just Google Python and R popularity, and I just took the first link. And this is really just a slide that says, maybe Python is something to look at and pay attention to. I just saw a tweet this morning that pretty much said Python just surpassed Java as the second most popular language in something, because I don't remember the rest of the tweet. But if it passed Java, I mean, that means something, especially for the enterprise world. So what is Python? Well, it is a general purpose programming language. Depending on where you are and who you are talking to, it may not be the best at everything or anything. But at PyCon, one of the things I did hear was it is probably second best at everything, and that's pretty good to be the second best language at everything. What Python does better than R, which is the only updates I've made since I finished my talk, was updating a few things, are how Python handles environments. So if you've tried to ever pin packages or R versions, it's a little bit more difficult than how you would do it in Python. Just the other day, a package called RM was released. So fingers crossed, that might make life a little bit better. And one thing objectively I can say Python does better than R is in the field or in the world of web development and hardware. So if you ever see this is a little circuit board by Adafruit, and it's running CircuitPython. So that is my name tag, coded in Python. So what I really do like about R is the world of communication. It does a really great job at if you have done a piece of data analysis and you need to present it to other people. So stuff like Shiny and R Markdown are probably, that is the reason why if I do an analysis in Python, it comes back into R, if only for ggplot or if only for putting it on a dashboard for Shiny. So the inspiration for this talk came from over the summer when Max Kuhn told me to say, hey, you're an intern, so you have to give this talk for me now. And I pretty much gave a 40-minute version of a 4-hour workshop on this is the differences between R and Python. So you can see those notes there. It was written in Jupyter Notebooks, and it uses the Rise Reveal plugin. And it was pretty slow. And what I realized right before my talk was I could have just used R Markdown Reticulate to create my slides. And so that's what this talk is using. So R and Python. So let's just give an example. We can use R to load a data set. So here is the Billboard data set from Hadley's Tidy Data paper. We can use dplyr and select to select some columns and rename the artist column. We can tidy the data set using tidyr. Right now we're using pivot longer, so that is the equivalent of spread in the previous version. And then we can use something like purr to do some additional data cleaning. One thing that if you didn't know, when you write something like function x, some kind of thing, and then x like that is exactly the same thing as this notation, this tilde formula notation. So if you've ever seen why people use this formula notation in a purr statement, just know that those two lines are equivalent. That period essentially is a placeholder for the letter x. So we can actually repeat that same analysis in Python. So we can load up pandas, which gives Python the data frame object. We can load up re for regular expressions. Emily showed the janitor package in R. Well, there is the equivalent package in Python written by Eric Ma called janitor that tries to implement the same things. I wrote a package called pyproj root and implemented the here function in Python, just like the version in R. And then we can load up and do our data analysis just like we did in R. And people usually give me a lot of grief saying that I like R over Python because Python doesn't have pipes. Well, Python kind of has pipes. It's called dot method chaining. And so you can see you can pretty much write your code and look down just like you would a dpyr pipeline. So how do you interact with R and Python? There is a package called Reticulate. It lets you call Python from R. It gives you a translation layer between R and Python objects. And it lets you load up individual Python environments. So how do we use this? We can load up the Reticulate library. I am in the data science field, and a lot of data scientists use Anaconda. So we are using Conda environments. This is just code because I was jumping around between Windows and a Linux machine. But I'm just using my default mini Conda environment. And we can use the use conda-env in that environment. And then what you have done is registered your Python environment in R. If you do this at home, realize that once you run use environment, if you want to pick a different environment, you have to restart your R session. Just running the command again won't actually change your Python environment. So we have this Python script. We have a data set, a data frame. This is exactly the same thing as before. And we can run something like a group by and a mean to get another value. And you can source this as a script if you want into R using Reticulate source Python. And you'll notice that you can actually just have those variables straight into your R environment, right? Like you source the Python file and all of a sudden like those exact variable names just exist. And here we get a vector, mean, rank by week, and then we actually get a regular data frame. And this is an R data frame, even though it was a script written in Python. And there's an entire translation layer between like R objects and Python objects. If they source, they just come into R. So for example, you just saw a pandas data frame object being loaded into an R data frame object. So let's go through another example for machine learning. So there's a library called scklearn. The API for scklearn was sort of the inspiration for MaxQn to put together Carrot and Parsnip, which was just a unified API to fit your machine learning models. Scklearn has a function called load breast cancer to load a breast cancer data set. And the weird thing about Python is there isn't really a consistent way of loading data from packages. So in scikit-learn, you get this thing called a bunch, but you can use like Seaborn to load up the tips data set, and you get a data frame object. So things are a little bit inconsistent, but you have to check the documentation for it. In the cancer data set, there is a column or there's a value called target, which is the response variable or the Y variable. There's also a variable called data, and that is the actual matrix. So scikit-learn runs everything on a matrix. It can handle data frame objects, but by default, everything is a matrix. We can use scikit-learn to train, test, split our data. So pre-processing is done through scikit-learn. We can use a min-max scaler to scale our data, and then we can transform our X training set this way in Python. And then we can create a support vector machine for classification using svm.fit, put in our training data, put in our value for our response values, and then we'll fit a model. And then by default, scikit-learn has the ability to score our data set. In this case, the default metric is called accuracy. So we can do that same exact thing in R. We can load up Reticulate, for example. You can see I'm loading up my Python environment using Reticulate. If I really wanted to, I can use Reticulate to load in that breast cancer data set from a Python library and create an R data frame out of Python libraries. So you can use it for that. And we can use a combination of R sample and recipes, which is the new way of creating machine learning pipelines in R, to essentially set up, train, test, split, and do our data transformations in R. And then we can use Parsnip to say, hey, this is the support vector machine that I want to fit. And you can get an entire table here in the official documentation for Parsnip. So the support vector machine comes from Kern Lab, so you have to make sure you have that installed as well. And then in R, there is a library called Yardstick that does the model evaluation. So here we can say Yardstick accuracy to get the accuracy score. And it should be pretty much the same minus the third decimal point. So I talked about communication. So we fitted a model. What about communication? So this presentation, it's written in R Markdown, Xerigan slide decks. And all of the Python code you see were actually just live executed in my presentation. So all I did was, in one of the earlier code chunks, I library Reticulate, set up my environment, and then I had a code chunk, and instead of R as the driver, I changed it into Python, and it will load up and execute my Python code. So all of the Python code you just saw was not copy and pasted, was actually live executed. And I hit init on this thing 2 days ago, and not as I was plugging in the, the projector like I did last year. So sharing objects between R and Python. So in an R chunk, if you are using R Markdown, you can access all of your Python variables using $py $. So you get a variable called py, and you can say $py $, and access everything from the Python environment. Likewise, if you created variables in an R chunk and you want to access, if you created variables in an R chunk and you want to use them in a Python chunk, you get a variable called lowercase r in Python, and you can access all of your R stuff using r dot. Notice it's a period, r dot, and that's not the end of a sentence dot. So in a Python chunk, I can, for example, this is the test data set, and I'm just saying, let's just get the first row of our data set, and this is our Python data set. And in R, we can say, hey, $py $, give me that variable from the Python world and save it to a single observation in R. So now I get an R object from a piece of code that was executed in Python. So you can do that and create variables in one language, create variables in another language, fit models in one and the other, and just pass stuff around, right? So we created this SVM object in Python, and we can say, hey, in this SVM object, just run a prediction, right? So in this example, it's kind of like nonsensical. I'm using my test data to do a prediction, but we can say, hey, here's this Python object, go make a prediction. But here's also this R vector, and pass that into my Python model object, and they both work. So you can do the same thing the other way around. You can make an R prediction. The way we make prediction of models in R is running the predict function. So R, we had a support vector machine object in R, and then we can pass in the R data. Remember that R data came from a variable that we captured from Python. So you can have variables or inputs from Python world and then plug it into an R model object. And then, of course, there's Shiny. What I've shown so far were all the pieces that you can then input into a Shiny model, right? You had an R variable that can now just be a reactive thing, and then you can create a Shiny object out of this. So the first thing you want to do if you have a Python model is you need to save this out. So there is a library called joblib that is essentially like pickling or creating a binary format. You can save out your Python model. And then in R, you can load in that Python model. So here's an example. So I actually have 2 slide decks this year. So this is a R Markdown document using Shiny as a backend. So this is my way of mocking up a Shiny app. So somewhere in your Shiny app, you're going to library or load up Reticulate. You're going to find the environment that you want to use and enable that Python environment. We can get our data from scklearn. So this is the exact same code that we did before. Because this is in R Markdown, all I did here was wrap this around a Python chunk instead of an R chunk. And then we can load up the 2 libraries that we need to load that Python model object. So my previous slide saved out this Python model object, and in this slide deck, I am loading in that Python model object into an R, in this case, a Shiny app. And then here's just the use case. We can say Python model.predict and give it some vector, and it'll just give us a prediction. Whatever value of this row just said that, no, you do not have breast cancer. So we can do the same thing in R, py $ model, $predict. So we can get the Python model from the Python world, call the predict function, pass in variables that way. So that's all the pieces, right, for Shiny. So now in Shiny, we have to have some kind of widget object. So we have an input panel just so you see something, and we have a slider input. this slider input just, all it is really doing is giving us how many rows in the test set that we'll plug in to our model to run a prediction. And so this is a $Python model. So this is an actual Python model. We are taking the Python test variable. But then here you're saying, you see input $, that is a shiny variable. And so now, if we move this slider and we go to 9, we get 9 predictions. This is a variable, this is a shiny object that we captured using all of the shiny framework, and we're pumping it into a Python object. Isn't that cool? Please go wow. So the down ecosystem, so I showed you shiny and bits of our markdown. This pretty much works for everything, and I haven't tried it yet. So there is like that book that I wrote, and it's written in LaTeX, and like Sam said, let's not use that. So there's something called book down, so maybe I'll just write everything in book down, but even though it's a Python book, fingers crossed, everything works. Blog down, the Hugo academic theme actually supports Jupyter Notebooks, so you can actually blog with Jupyter Notebooks, and it will render your Jupyter Notebooks in as a blog post. Some stuff in the Python world, I guess they realized that, hey, this stuff by RStudio is pretty cool. So this year, I learned of a package called knitpy or knitb, which is the knitter implementation in the Python world. And if you are in Jupyter Notebook world, there is a system called Jupyter Books that lets you use a Jupyter Notebook for an individual book chapter. It sort of works like book down, but it is a different system. You can create reticulated R packages. I'm not going to show you this, but just know that the rkeras package is really reticulate in Python, just wrapping around the Python API. So if you load up keras, you probably have realized you really need an entire Python stack installed. And this is really just, hey, Python has all of these problems solved already. Let's just, write a nicer API on top, and that's how keras in the R world was created by the folks at RStudio. One thing about installing Python, if you try to come back here and follow along, is I am a software carpentry instructor, and so I always point people towards the software carpentry instructions. For those of you who took my Git training yesterday, you would have noticed that I also just sent you Git installation instructions, and things got a little bit confusing in terms of the syllabus. But most people in the data science world use Anaconda to install Python. So if you want to install Python and not bork the rest of your system, give Anaconda a shot. The way you uninstall it is just deleting a folder, so it's pretty harmless in that sense. One thing about conda. So there's this wonderful website created by Jenny Bryan and I think Jim Hester, I'm not sure, folks at RStudio. It's called rstats.wtf. It's got a great URL. And it's about things they forgot to teach you about R. There is a section in there about using conda with R. And the main thing is when you install Anaconda, you do have the ability to install R and R packages within using the conda package installer. And if you are trying to follow along, the main suggestion is pick one of those systems and stick with it. And the one I recommend is if you're going to install R packages, just stick in the R world. So don't mix and match conda install with install.packages. You will be very confused where things are if something were to happen. If you followed my talk last year, I talked about project workflows. Wes McKinney, who works for Ursa Labs, runs a project called Apache Arrow. So if you are sharing objects between R and Python, give Apache Arrow a shot. It is a very fast and efficient way where you can store and pass along data frame objects between R and Python. So if you do have large data sets that eventually need to be loaded into Spark or Hadoop or read and write Parquet files, look into Apache Arrow, and it'll integrate very well with your R and Python world. And so that is my talk. If you want my slides, they are at the bottom of every slide deck, but if you need to take a picture, here it is. Thanks.